Hello, my name is Corey Smith, and I would like to introduce you to some biofuel and land use basics associated with biofuel production. And as a group, we'll explore our current state analysis, where we are headed, and where we would like to be, and some potential options for the future. Thank you for joining us. Biofuels are categorized as any liquid fuel derived from biological matter versus ecological matter. Biofuel use is not a new concept. From as early as the 1800s to times of war to present day, combustion has been made possible by utilizing alcohol and various oil types. The various processes used to derive these fuel types include fermentation, or by capturing gases produced by decaying organic matter. Just a few of the many fuel stocks include corn, soybean, potatoes, sugarcane, and various oils like canola and peanut oil. Deforestation, harvesting, and the lack of appropriate infrastructure are the crux consequently causing the biofuels revolution to backslide. Current carbon dioxide emissions generated from today's processes and production practices are greater than or equal to the net benefit resulting from biofuel use itself. We are not quite there yet. We've identified sustainable options for replacing our demands on fossil fuel. Research is still in its infancy and gaining momentum. Climate change is affecting all biogeographical systems on our planet, which means every last one of us are stakeholders. According to Schwartz, climate scientists say we need to reduce global emissions by about 4% a year, going to zero emissions before the end of the century. That's not a whole lot of time to get us from where we are to where we need to be.
Current state analysis. Biofuels are widely used in many countries around the world as the world strives to find a renewable energy source to end dependency on fossil fuels and help lower the emissions of greenhouse gases. While biofuels such as ethanol emits less carbon dioxide than fossil fuels, land use change releases carbon dioxide right back into the atmosphere. According to the USDA research done by Dr. Alex Farrell, Director of the Transportation of Sustainability Research at UC Berkeley, showed that an acre of corn production for ethanol in the United States would ultimately lead to an acre of tropical rainforest conversion at conversion costs that go as high as 826 grams of carbon dioxide per megajoule of energy from corn ethanol. The current stakeholders in this wicked problem are governments through policy, non-governmental organizations through lobbying or by influencing public opinion, the commercial and industrial sectors, and American consumers who are affected by fluctuating food prices and global warming. What has initiated, exacerbated, and perpetuated the issue of land use change for biofuel production is the government's inability to understand and accept the research and create policy to address global warming, and continuing to rely on finite resources for energy. While some presidential administrations have taken steps to help combat global warming, others have showed lack of interest in scientific research and helped the fossil fuel industry instead. The effects of this inaction when it comes to global warming has led to the unsustainable production of biofuels. Thankfully, more research is being conducted to produce a new generation of biofuels that is cleaner and sustainable, like algae, although it has not yet been mass produced.
Hi, my name is Elise, and I'm going to be talking about transitions within biofuels and land use change. So, how do we get there and make sure that we are on a sustainable path? We look at our indicators, we look at strategies, we look at our barriers, and we look at fundamental changes that we need to make within our society. Because biofuel production through land use changes causes more CO2 emissions by deforestation and increased industrialized farming, our indicators across all four phases remain the same. So by measuring the CO2 emissions, we are provided a clear indicator in which direction we are headed. And the different strategies to get there are education, subsidies and publicity, taxes, and policy change. Different barriers that arise when we try to make these changes include cultural resistance and fears, political support, implementation troubles, and political support. And one of the biggest fundamental changes we can make is to acknowledge that human activity does indeed contribute to the increased rate of climate change and to value our natural resources.
Increasing political, economic, and environmental security concerns are linked to energy dependence. Bioenergy is expected to play an important role in the global energy mix in the foreseeable future. However, the rapid growth of food-based biofuels is controversial, and issues of food security and potential ecological and environmental problems are often discussed. Currently, most biofuels are made from food crops like corn and soybeans. This raises major nutritional and ethical concerns as growing crops for fuel consumes land, water, and energy resources that could otherwise be used in food production for humans. In the United States, 13 million hectares of cropland is required to produce 37 million liters of biofuel. This is about 7% of the 179 million hectares of national cropland. To meet the 2022 biofuel mandate, another 15% of the cropland will be used in the United States for biofuel production. Producing biofuels from food threatens food security not only in the United States but also in other countries, especially countries that have populations suffering from malnourishment. Studies show that conventional food-based biofuels contribute to monoculture and deforestation, which jeopardizes ecological biodiversity and ecosystem services. Furthermore, some biofuels are not competitive with existing fossil fuels and may result in negative energy returns and net greenhouse gas emissions. To date, conventional biofuels manufacture has important limitations, and the production may not be able to keep pace with the fast-growing industry needs and energy demand. These problems limit further development of the conventional biofuels. Second-generation biofuels are expected to help solve these problems and to provide a considerable proportion of the fuel supply sustainably, affordably, and with greater environmental benefits. These biofuels are derived from lignocellulosic crops, and the biomass feedstock encompasses a wide range of sources such as food crop stalks, forest residues, and grasses. Food crops like corn and soybean will be consumed less for biofuel purposes. Biofuels derived from well-managed energy crops provide more usable energy, higher greenhouse gas reductions, and less agrochemical pollution than conventional biofuels. Perennial energy crops like switchgrass require less water and nutrition input and produce much higher biomass per hectare for biofuel use than food crops, and can be produced on degraded or abandoned agricultural land, eliminating the competition with food production for cropland and without causing a loss of biodiversity via habitat destruction. Even though food-based biofuels currently eat up most of the bioenergy market, the majority of increased production after 2020 is expected to come from the second-generation biofuels.
Biofuel, an old technology with a hopeful new implementation, has been revisited to solve the issue of carbon emissions from fossil fuels. The Energy Independence and Security Act of 2007 was passed, and it intended to increase the use of biofuels from 6 billion to 36 billion gallons in 15 years. Now, just 4 years from the end of that period, it appears that there was more hope than success with this program, since the impact of indirect land use change may have had more of a negative impact than positive. Since the turn of the 21st century, scientists such as Searchinger and his team have been studying the risks and rewards of the biofuel industry. This includes indirect land use changes caused by the use and increase of biofuel production. Therein, it has been determined that in order to create a positive impact, there must be precautions taken. There have been some guiding ideas presented for the transition to a more sustainable biofuel industry. Therein, one of the most important actions that can be taken to continue reducing the carbon impact is the maintaining of land and energy efficient farming methods. This can include things such as transitioning from already cultivated land instead of deforesting more land to accommodate for the acreages needed to grow the necessary biomass. The removal of trees can cause carbon debts and that can take hundreds of years to replace. Efficient farming can also include the reduction of fossil fuel driven equipment with new technologies such as electric options. Another important action is funding the research to improve the measurement of the indirect land use change itself. Models such as Aram Week's Transformational Sustainability Research Framework, published in 2016, will help us to better create models for more accurate measurements. When agreeing to the creation of long-term commitments, stakeholders must have accurate expectations of the indirect land use change caused by the biomass production to ensure sustainability as well. For the production of 1 billion gallons of biofuel, 70 tons of biomass are needed, and depending on the type of biomass used, the acreage yield can be different. Maintaining a healthy acreage that will not create carbon debt is imperative to ensuring that this is a sustainable solution. Thus, continued monitoring and regulation are necessary to ensure appropriate land use practices are then utilized to lessen the effect of indirect land use change.